Hello and welcome to yet another video of Cornerstones of Math, and welcome to yet another recurrence relation video. In this video, we are going to solve the recurrence relation a1 equals 2 and an plus 1 is given as n times 2 to the power of n plus the summation of ak divided by k, where k goes from 1 to n. Needless to say, the given recurrence relation looks quite complicated, and we need to utilize the given recurrence relation to obtain the easy relation, which you might have encountered more frequently. First, consider this. Using the given expression for an plus 1, how can we express an, the nth term? Well, we can simply replace n with n minus 1 in the given recurrence relation. Then we obtain an equals n minus 1 times 2 to the power of n minus 1 plus sigma ak over k. Now k is from 1 to n minus 1. Here, since the given recurrence relation is valid for natural numbers greater than or equal to 1, this expression for an is valid only for natural numbers greater than or equal to 2. That is, we cannot substitute n equals 1 to obtain a1 using this relation, which is pretty obvious. And now comes what seems like rather unusual procedure. I am going to calculate the difference an plus 1 minus an. But why? Well, because if we do that, then the sigma notation disappears. More precisely, an plus 1 minus an is equal to n times 2 to the power of n minus n minus 1 times 2 to the power of n minus 1. And then, if we do the subtraction this minus this, which is the summation of first n terms minus the summation of first n minus 1 terms, then all that is left is merely the nth term of the summation, which is an divided by n. And let's don't forget this n greater than or equal to 2 condition. So an plus 1 minus an is equal to 2 to the power of n minus 1 as a common factor. Then we have 2n here minus n minus 1 here. So this plus an over n. So an plus 1 minus an equals n plus 1 times 2 to the power of n minus 1 plus an over n. So moving this term to the right hand side and combining with this, we have an plus 1 is equal to n plus 1 over n times an plus n plus 1 times 2 to the power of n minus 1. And this is the easy recurrence relation. Do you know how to handle this kind of recurrence relation? Well, this is one of the special recurrence relation in the sense that we have n plus 1 here and n plus 1 here and n here and n here. Therefore, if we divide both sides with n plus 1, we obtain an plus 1 divided by n plus 1 equals an divided by n plus 2 to the power of n minus 1. Here we can make a substitution, an over n equals bn. Then the left hand side is bn plus 1, so we have bn plus 1 equals bn plus 2 to the power of n minus 1. This is even easier kind of recurrence relation because we are now given a recurrence relation in a difference sequence form where the difference bn plus 1 minus bn is given as 2 to the power of n minus 1. Here, when the difference between two adjacent terms are given, we can obtain the general term by the following tip. When difference sequence an plus 1 minus an is given, the general term an can be obtained by the first term a1 plus the summation of the difference sequence ak plus 1 minus ak, where k goes from 1 to n minus 1. It is important to remember that the summation only goes up to n minus 1 and not n. But in our case, this expression for the difference sequence applies for n greater than or equal to 2, so we need to tweak this formula a little bit. That is, instead of b1, we start from b2, then we have the summation part. And you can easily understand that now the summation must be carried from k equals 2 to k equals n minus 1. Then the right hand side will give the result bn. Here, b2 is equal to a2 over 2. And from the original recurrence relation, we can find the value of a2, which is 1 times 2 to the power of 1. And the summation part in this case is only a single term, a1 over 1. And since a1 is equal to 2, we have 2 plus 2 over 1, which is 4. Therefore, b2 equals 4 over 2, which is 2. So we have 2 plus the difference sequence, which is 2 to the power of k minus 1. This is the partial sum of a geometric progression, and we have a formula for that. You must remember that in this formula, n right here refers to the total number of terms in a summation. In our case, the first term is when k is equal to 2, so it is 2 to the power of 2 minus 1. This times the common ratio 2, and since k changes from 2 to n minus 1, we only have n minus 2 terms in the summation, so we have the power of n minus 2. So 2 to the power of n minus 2 minus 1 divided by 2 minus 1. So we have 2 plus 2 times 2 to the power of n minus 2 minus 1, which simplifies to 2 to the power of n minus 1. Therefore, from an over n equals bn, we have an equals n times bn for n greater than or equal to 2, which gives an is equal to, when n equals 1, it is simply defined as 2, and when n is greater than or equal to 2, we have n times 2 to the power of n minus 1. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.